How do you know when a relay's bad? That's what we're going to show you. Just about everything in your vehicle is either powered through a fuse or through a relay, or not really powered by a relay, but the power will flow through a relay, which acts almost like a switch. It does act like a switch. But anyway, how do you tell when it's bad? Because you pull them out and you look at these 4 or 5 prongs and you go, I don't know, does it click when I put it in? Do I hear it click? Well, what's happening? Well, we're going to dig in and actually tell you and show you what's happening. We'll tell you how to actually test these things, and stay towards the end, because then we're going to help you on how to diagnose your wiring if it's actually not your relay. What is the best way to test whether a relay is good, and how do these relays work anyway? I mean, some of these are 5-prong, some of them are 4-prong. You can even get 3-prong relays, and probably even more, but this is probably your most common, would be your 4-prong and 5-prong relays. These are all, I believe they're considered all Bosch style relays, but anyway, some are 5, some are 4, and some are wide blade, some are thin blade, some are different configurations, but they all tend to do the exact same thing, and that is basically act almost like a fuse, but more like a breaker, and even more so than that, because basically it enables you to power something without having to switch the high-powered source. And before I get that deep into it, let's go ahead and start talking about relays, and we'll get into how we power things in just a few moments. Now, a few things that you'll probably need in this process, or that will definitely help. One would be a multimeter. You can get cheap multimeters. This is kind of an all-inclusive multimeter that works good on 98% of the stuff you'll need. And I'll have a link in the description on this. You can get this on Amazon. Something else that is just, I wouldn't say it's critical, but comes in so handy, are just these little like alligator clips and wires and leads. And you can get this 10-pack here for like $6 on Amazon as well. So just very handy to have these, so you're not always having to, take wires and strip them and, use the bare ends to power stuff, whatever. And then if you do this a lot, or you like to power stuff with your wire leads, then you can get a little bigger set like this. These come in really handy. A little more powerful alligator clips on here, and they will handle up to 10 amps. So again, I can actually power stuff with these, not just test whether we're getting 12 volts to something. I can actually power up a starter motor or something like that. Now, you don't want to load on it with something like this, but still, you could actually run the power to it, spin the motor, whatever you're trying to do with this heavier gauge. And I think those are like $12. So a little bit more, but still, these are very handy to have. Definitely this kit here. And again, at $6, why not? Multimeter, some wire leads, and probably a 12-volt source. You could use a battery charger or jump box or something like that. I'm going to use a little, Milwaukee 12-volt battery. Should give us enough voltage to test these relays. Now, let's talk about these relays and how they work real quick, and then we'll actually dive in and test them. Now, you'll have a relay that powers your air conditioning. You'll have a relay that powers your fuel pump. Just about anything electrical in your system, if it's not a fuse, it's going to be a relay that's controlling that circuit. And the nice thing about the relay, again, is we can send small wires to it to act as the switch, almost like the light switch in your house, but we don't have to run that full amperage to that light switch. We can just power that with low wires like we see right here. So this could actually be controlling the switch circuit, and then what's actually powering, say, the radiator fans or xenon or LED headlights would be, a thicker gauge, say a 10 gauge wire running there that's actually doing the powering. So that's what helps in these relays, is again, from the switch inside the car to the actual relay, you're running real small wire that's easy to run, and then you just run from the relay to the actual light, or to whatever you're powering, your heavier gauge wire. But how do we tell if it's actually working or not? And I ran into this here recently. A fuel pump wouldn't work on an old Chevrolet truck, so we started running things down. The wiring looked good, yada yada. Wanted to test the relay, and kind of went back over in memory how to test these relays. So let's just write this out real quick, and you will see this on the side of most of the relays. Most of the time, it'll show you kind of an electrical schematic of how this relay works. Well, if you don't talk electricianese, then you might not understand what's going on here. But let me just draw this out a little bigger here. so we can talk about it. And most of these are pretty much the same. So 85, 86, and 87, and then 87A, and then we have 30. Okay, so those are most of the numbers, especially on a 5-pin relay. Now, if you're on a 4-pin relay, then what you won't have is this number 87A right there. No big deal. That's fine. But so if it's a 4-pin, you just eliminate the 87A. That's easy enough. And if it's a 5-pin, then you have an 87A. Now, what's going on here is what you'll usually see between 85 and 86 is this, which means there's a resistor in between 85 and 86. Well, that may not mean much to you either, but basically this is your switch side, or your control side of the circuit. This is your, not low voltage, but this would be your lower control amperage, lower load on the system. And in fact, there's not much load at all. You're actually powering this with a low amperage wire, or just all you're doing is basically flipping a switch. So that's what comes in. One of these is negative and one of these is positive. It really doesn't matter either way. It's not that smart to care nonetheless. So basically this is your power coming in and your ground coming in right here. Now sometimes your ECU or your CPU may be controlling the ground side and or the power side. So you don't always just have to check the power, you have to check the ground as well. But again, let's talk about the relay. So we have 85 and 86, and then on a 5-pin, what we'll have, 30 is actually going to be your big power coming in. So this is your positive coming in. Maybe I'll draw that like this. There we go. So this is the positive coming in. This will be your heavy gauge wire if it's something heavy, because some of these are 30 amp, some of them are 40 amp, but we can control 30 or 40 amps with this style of breaker, depending on which one it is. But this is your line coming in. So we've got positive 12 volts of power coming in on number 30. Now, if it's a 5-pin relay, then what happens is this. And this is your switch. And basically this means that when this switch is not activated, when there's not power coming here, that this side is closed. So in other words, power is coming into 30 and flowing through to 87A. So there's no power coming through to 87. Now if you're on a 4-pin, that just means that there's no power going to 87 yet. Now when this is energized, so when there's power coming to this, then that means that this circuit closes, and now we've got power going to 87. So on a 5-pin, it means, okay, it went from 87A to 87 when this was powered. And again, we'll show you this here in one moment. And so that means now 87A is not powered. Well, where would you use this? Well, you could do things like under normal, just key on. Maybe your electric cooling fan is running, and maybe you have 2 fans, or maybe you have a low high speed. And then once the AC trips on, maybe it sends power to this relay, then calls it over to 87 and kicks it into high, or kicks the second one in. So that's where you could use the 87A and the 87. Otherwise, it could just be your lights, and once you turn the light switch on, then it calls this on. And again, rather than running a brand new wire, which this works in really well for, say, your muscle cars, things like that didn't have big wiring going to those old incandescent bulbs. But now you want to throw a xenon or an LED, a high-powered LED, well, those draw some amperage. And so you don't want to be running that through the switch, all that high power flowing through that old switch, and you could run that lower wire, that smaller wire, to the relay, and then run you a new wire from the relay to the headlight. So let's actually test this procedure here with one of these relays. Let me grab this one here since it's got larger blades on it. It's just easier to figure out. And while I'm doing that, let me just show you here. Most of your relays, in addition to having the little schematic there on the side or on the top, it also has the numbers on the blades, because the blades don't coincide with the positions that you see here, by the way. And let's see if I can get this to show up here. Little silver on here might stand that out a little bit. No, I'm wasting my time. That didn't show up. Here's a better one. So that one kind of showed, but you can see the numbers actually show up on each one of the blades. So you're not in the blind when you're doing this, even though you can figure it out as well with your multimeter. So I'm going to turn my multimeter on. And this one's pretty cool because I don't actually have to switch it. It actually senses between ohms and voltage and DC and AC voltage, and as well as continuity. So it kind of is smart in a way. And the first thing I can do is check resistance across 85 and 86. So I want to find 85 is here, 86 is here, and again, it doesn't matter which lead is on where. And you will see I get 85 ohms of resistance. Now, most of these should run somewhere between 75 and 100. You might get a little over that, but typically most of the ones I test are between 75 and 85 or 75 and 90, something like that. And that should be kind of a normal resistance across the switch side of the relay. Now, also what you can check here, I can check across 30. Remember 30 I said is the power coming in, and normally closed is 87A, which means the power is typically without any power going to it. The power is coming into 30 and out to 87A. So I can find 87A, which is in the middle, and I can check across 30, and I should get the beep sound. There we go. So we've got continuity across that. So we've got a closed connection. This wire is actually flowing from 30 all the way through to 87 now, and I should not get that on 80 or on 87. I should get it on 87A and not on 87. So there I've got an open circuit. It's not recognizing anything, which is correct. So again, across 85 and 86. I'm getting my 75 to 90 or 75 to 100. I'm getting 85 ohms. Across 35 to 87A, I get a closed circuit. And 30 to 87, I'm getting nothing, an open circuit, which is the case. Now, when I power this, I should see it jump from 30 to 87 and not be closed on 87A. This should be open. So the switch should flip over here and power should be going to there. So I'll take my little battery here. And I'm going to send power to 85. And then I should be able to hear this click when I touch 86. I held that up to my mic, so you should hear that. So it's clicking. So I know it's working per se. But let's check that. So now we've got that. We checked it without power going to it, right? We had power going from 37 to 87A. Now we should have an open circuit on 30 to 87A. And we do. We've got an open circuit now. And now we should get continuity. So now we switched from going to 87A, and now 30 is flowing through to 87. So now we know the relay is working in its idle situation, where now we could power through from 30 to 87A. And we also know that when we get power and ground to the relay, that now it's working from 30 to 87. Now real quick on a 4-prong, as I was mentioning, the only thing we're not going to have here is 87A. So basically, we should be able to test resistance across it. And we do. We're getting 78. So we're getting 78 ohms of resistance, 82, 80. So 80-ish ohms of resistance across the switch side of the relay, which is correct. So under its normal state, we should have no continuity here with the relay. Now, if we power the relay, we should hear it click. We hear it click. Now we should have continuity across these two. And there we have it. So now it's in a closed state. Without this, we're in an open state. And again, one more time. Now we should be in a closed state again. There we go. So we've got continuity again. So 4-prong, all we're doing is eliminated 87, and it's either powered up or powered down. It's not switching between two different components. All right, I've got a cool little board hooked up here that should be able to kind of show us how we can control two different things with one of these relays. So what I'm going to do here, I'm going to put this relay here in the middle. Okay, so here's what I've got going on. If you can kind of see my mess here, is I have power going to the relay on the switch side on 85 and 86 or 86, and then I have power going to 30 as well, simulating that would be our power waiting to go out. And you see in its switch state right now, because actually I have power going to it, then we've got the light coming on. Now when I turn power off going to the switch, it's going to return back to the 87A state, and it's going to power something different. So watch this when I take power off of the resistor side of the relay. So right here, I'm going to take power off the resistor side. Now the light turns off and the window motor came on. Turn that back on, and now we got power to the relay, and it's powering the LED, and now it's the window motor. So in this case, when there's power going to it, it's running something, and when there's not power going to it, it's returning back to its restful state and then powering, in this case, the window motor. I know that doesn't make sense of why you'd run a window motor, but you get the fact that it can run one thing until it calls something else on, or it could run a high-low, something like that as well. And now let's just quickly open one of these up. And pretty simple what's going on here. So again, I'll go to 85 and 86. And we'll look. And you see the coil. And then once it's energized, you'll see that gap closed right there. So once I energize this, you'll see the little gap closed. It almost looks like points. So that's all that's happening when we energize that relay, is that's closing that circuit or switching the circuit from 87 to 87A, or just turning 87 on. Hey, by the way, I highly recommend, you should already have a multimeter if you're working on vehicles, and they're cheap to buy. You can buy these things pretty cheap, you know, whether you're kind of buying a more conventional style or like this one here that's kind of almost like a phone and kind of does a lot of automated stuff. Whatever, just make sure you have a multimeter, as well as these wire leads, as I mentioned, like $6 for this 10 pack, $12 for these longer leads that are also carry like 10 amps. So highly recommend those things. We'll have links in the descriptions, or you can find them on your own, but they're cheap to buy and they're very well worth it. Well, really, when you break this thing down, it's really not that difficult to understand. Now, every time I have to kind of think for a second to remember all the things that I used to know, you know, the month prior before digging into relays again. But really and truly, it all makes sense on these, whether it's a 4 or 5 prong relay, it doesn't matter. You can kind of figure it out that either, you know, 87A is naturally powered, and then when the switch comes on, it switches to 87, and you understand how the process all works. And once you understand this, it makes it a lot easier, especially when you're building those resto mods, or you know, restoring those old cars and putting updated electronics in them, and not have to rewire the entire car, because now you can use relays, and you don't blow fuses anymore, and you don't burn up old wiring. You can use relays and circumvent a lot of that and power them the right way, and you don't have that voltage drop like you would if you're using that old wiring. Now, how do you fix it if you realize, man, it's not my relay that's bad? Well, that's a great question. Well, we know that 85 and 86 on here are the low side or control side. Control side is a better word, better term. The switch side, the coil side of the relay. We know we need a power, a 12-volt power source, and we need a ground. Now, as I mentioned, be careful, because it may not be the power side that switched. It may be the ground side. Many ECUs or CPUs, the computer in the vehicles, like to control that ground side as well, or just the ground side and not the power side. So just because you have power don't necessarily mean that you have ground as well. So make sure, do some continuity tests and test from the ground on that side to the ground on the car, to something grounded on the car, and tell if you have ground or not, and then maybe key it on and see if maybe that ground comes on. But anyway, now you know that, hey, if I've got 86 is my power side, check. Do you have 12 volts coming to that when that switch is on or when that key is on? Check, do I have ground on the 85 side or the 86 side? Make sure you've got ground and positive on one of those. And then, okay, do I have power coming to 30? So we know whatever prong, wherever the number 30 prong is fitting in, I should have power going to that when that switch is on, or when whatever's powering that should be providing that 12 volts of power to that number 30 slot. And then, do I have continuity from 87 or 87A to whatever I'm powering? So now you can understand that you can really diagnose, and really you can eliminate all the good things, leaving you with only the bad things, and you're really shrinking down that opportunity of what can be bad in there, and help you actually diagnose what's going on with your wiring. Hope this helps you. Let us know in the comments what you think. Also, follow us on Instagram, Facebook, Twitter, and even TikTok. And if you don't mind, would you hit that like and subscribe button if you haven't done so already? And by all means, if you hated our video, then give us a thumbs down. But would you let us know in the comments why? Have a great day and keep smiling.